Alright, so today we're going to talk about how to solve a quadratic equation using the quadratic formula. So this is the third method of solving a quadratic equation. We talked about factoring, we talked about completing the square. This is pretty much the brute force method of solving quadratic equations. So again, follow along Glencoe Algebra 2 textbook, 2018 edition, section 3.6. So again, like I said, it's the brute force method of solving quadratic. It doesn't have the elegance of factoring, looking for numbers that happen to do a product and a sum to rewrite it as a FOIL method. It doesn't have the elegance of completing the square, where you get the left side to be a nice, perfect square trinomial, so you can do the square root, all this wonderful stuff. This is where it doesn't factor, you have nasty numbers in the A and B spots, and this is just going to always work. This is also if you were to write computer programming code. Like I know I have an Excel spreadsheet that works out solving quadratic equations. This is what I use for it. Because it's kind of tough to write it out so it does a reverse full kind of method of completing the square. Even if it's possible, which I'm not 100% sure it really is, it would take way too much lines of code and it would be a total mess. Whereas here you just tell it to plug into this exact formula right here and it can shoot out an answer for you, no problem. So the key is identifying your A, B, and C values and plugging into this formula. Negative B plus or minus square root B squared minus 4AC all divided by 2A. You need to make sure you know this. This is a very important formula to know for this section. If you YouTube songs to remember the quadratic formula, I'm pretty sure there's always one flowing around where it's pretty much sung to the theme of Pop Goes the Weasel, which kind of sounds a little weird and kind of strange and lame a little bit, but hey, if it helps you remember, that's fine. Whatever helps you remember it, you can think of something on your own, that's great. If it's creative enough and obviously appropriate enough for school, feel free to share with the class, and I don't know, maybe we'll do some sort of extra credit points or something like that. Alright, so for this one right here, we need to identify A, B, and C. So A is positive 8, B is 3, and C is also positive 8. So from here, we now plug into our quadratic formula. So x will equal negative b plus or minus square root b squared minus 4ac all divided by 2 times a. Alright, so this becomes negative 3. I don't know why I wrote 9 there. So it's negative 3 plus or minus the square root of, there's our 9. And then 4 times 8 is going to give us 32 times 8, which is 256. So minus 256 over 16. Alright, so negative 3 plus or minus. So if we do 9 minus 256, we get a negative 247 over 16. So the negative is going to tell us we're going to obviously have a imaginary number in there, so the key is whether or not we can simplify the square root of 247. And if you actually look at it, again, it's a rather large enough number. I'm not 100% sure if it's prime or not. But like I said, if you were to actually graph the y equals 247 divided by x, and then go to the table of values created from that, you'll find as you go through there are no other factors besides 1, 247. There's a 13 and 19 factor, but those are both prime, so it's useless, and then that's it. So it's only 1 and 247, 13, 19, none of which are perfect squares. So all we can do is negative 3 plus or minus I square root of 247 over 16. And that'd be our final answer. Alright, so pretty much it's not like a hard process to solve this right here. It's just going to get a little bit of much of a pain for the inside the square portion. Like I said though, use the graphing calculator, use your table function if you graph it to see what it equals, and it'll really help you out find your factors. It has to equal 0, so if it doesn't equal 0, we have to always rewrite. So we have 5, that was weird. So we have 5d squared minus 7d minus 4 equals 0. Always make sure, again, it's still in proper standard form. Our A value is 5, our B value is negative 7, our C value is negative 4. So in this case it will be D equals, because it's D squared, so it will be negative of negative 7 plus or minus the square roots, negative 7 squared minus 4 times 5 times negative 4, all divided by 2 times 5. So we get 7 plus or minus the square roots, 49 plus 80. 4 times 5 is 20, times the 4 is giving us the 80. It's a positive here because the negatives will cancel out that. Divided by 10. So this becomes 7 plus or minus the square root of 129 over 10. So again, if we take a look at the factors of 129, so again, to help out, if we do y equals 129 divided by x, go into our table of values, we see that, as we go through it, so obviously 129, 3 and 43, and then after that, there isn't anything else it looks like, because 43 itself is prime, so that's it. So we have no other perfect squares, so there's nothing to simplify with. It's just 7 plus the square root of 129 over 10. Again, if the square root happens to simplify, then obviously you simplify it, and then we go from there. Alright, so let's take a look at just one more. So we have 12x squared minus 9x equals negative 11. Let's move the negative 11 over. 12x squared minus 9x plus 11 equals 0. So a is 12, b is negative 9, c is positive 11. So x equals negative of negative 9 plus or minus negative 9 squared minus 4 times 12 times 11, all divided by 2 times 12. So we get positive 9 plus or minus square root 81. And then 4 times 12 times 11. 4 times 12 is 48. Times 11 is 528. So it's minus 528. Stayed negative. There was no negatives to cancel with that negative 4 there. Over 24. So if we do 81 minus 528, we get the square root of negative 447 over 24. So obviously, again, we're dealing with an I. The question is, does 447 simplify in any way? And if you go through again, your y equals 447 divided by x. 447 divided by x. You go to your table, and we see that, so obviously we have our 1 and 447. If you kind of go through the rest of the list there, I'm not really seeing anything else. 3 and 149. But I'm going down the list there with the x's. I'm not seeing any other y that come out to be nice whole numbers there. So, pretty sure, again, it's a long list. After a while, you can pretty much kind of like give up at that point. It's pretty clear that it's not going to work. But yeah, that's as far as it goes. So we have to make sure we do the I. So x equals 9 plus or minus I square root of 447 over 24. Now, the 24 and the 9 can be simplified individually. And if we separate this out as two separate fractions there, then we would have that. Generally, in quadratic form, we want to leave it in this form right here. That's why we're not separating it out as two separate fractions. If you want to, write it as 9 over 24 plus or minus I square root of 447 over 24. That's fine. In which case, the 9 and 24 divided by 3 to make it 3/8. But don't cancel it if you're leaving in this form right here, because if in the current form, you need to make sure that every term is divisible by 3, not just 2 of the terms. Alright, so that's your quadratic formula. So that's your third method of solving. Ultimately, again, how you solve is up to you. Factoring is generally the easiest method to do by hand. If you notice it doesn't factor, then it's your quadratic formula or completing the square. One bit of advice, though, to help you out, something like that, again, if you have the graphing calculator, if you were to graph the quadratic and see where it crosses the x-axis, there's your solutions. And if it never crosses the x-axis, like this one right here would not, then you have no solutions because it's only imaginary results. In which case, then you have to go back to your quadratic formula. Alright, so that's it for the methods of solving quadratic equations. We are also going to talk about how to solve a quadratic inequality, but that'll be for the next video. So I'll see you next time.